This meeting is being recorded.
Focus.
For problem 12 from chapter 7, we're asked to predict both the major and minor products for each of these E2 reactions. So we're told that each of these reactions will occur following this E2 mechanism. So we're given a substrate and we're given a base as our reagent. So depending on the substrate and the base, we are going to generate different major and minor products. So let's take a look at our first substrate. We see our alpha carbon here, and we see 1, 2, 3 distinct beta carbon positions, and only 2 of these have hydrogens available. So there's hydrogens available here, and there's hydrogens available here. So this site we will ignore for our discussion of the products that would form. So if we were to remove what we will call proton 1 here, so we would have an elimination that occurs and a double bond formed right here where that arrow is. This would be our major product, which would be a Zaitsev product. And again, that would be the more highly substituted alkene that's formed. So this again is our major product. And then if this, we'll call this proton number 2 up here at this second beta carbon site, if that were removed along with the chlorine, then we would see this product, the Hoffman product, formed as our minor product. And again, depending on the base, so this is a non-bulky base, so the more highly substituted, again, Zaitsev is our major product. Let's take a look at a similar substrate, and now we have a bulky base being used. So once again, we identify our alpha carbon and then any beta carbons. And what we see, we have 2 unique sites where protons are available to be deprotonated. So we have site number 1 here, and then we have 2 of the same beta carbons below. So these would produce the same product rather if elimination occurred with either one of these sites. So we'll draw our product based on elimination over here. So our major product now would be the least highly substituted Hoffman product that could result, and we'll draw that elimination with beta proton number 1. And again, this would be our major. And our minor product now would be the more highly substituted Zaitsev product. So that would look something like this. All right, so I'll move a little more quickly now that we know how to, how this product prediction works. So now in compound C, we have 3 beta positions to consider. So we have 1, 2, 3. Again, that's our alpha carbon. So only 2 of these would produce unique products. This is a non-bulky base. So our major, more highly substituted Zaitsev product would look something like this. And our minor Hoffman product would look something like this. Now let's take a look at compound D, and once again, we identify any of our beta carbons. We only have 2 unique sites. We have a bulky base, so now our major product is going to be the Hoffman product. So that will be this product here, and then our minor product would be the same product that we saw last time as our major product, the Zaitsev product, the more highly substituted. So C and D have the same products. We just switch between which is the major and which is the minor based on the fact that we have a non-bulky base versus a bulky base. So we'll see the same thing here happened with E and F. where we have a non-bulky base and a bulky base. But let's see what happens when we predict what products could form. So here's our alpha carbon. So we have 3 beta carbons shown, but they will all produce the same compound. So we would say these positions are identical, and that's what we see over here as well. So actually, we're only going to produce a single product for any of these reactions that would occur with this substrate here, since it's the same substrate, and all of the beta protons are identical. So both of these reactions, we would produce a product that looks like this, which would be the only product, again, for both this reaction here and reaction F.